Okay, so we finished with a problem that you were supposed to compute yourself, the region in the first quadrant that we were talking about, bounded by the parabola y is equal to x squared. Okay. The y-axis and the line y equals 1 is revolved around the line x equals 1 to generate a solid. Find the volume of the solid. Okay, so who wants to talk me through this problem? Where's my region? Here, is this the same region? Yes, it is. So y equals x squared, y equals 1, and the y-axis. So I think that's the same region. Okay. So let's go back to this region. Okay, I don't like that. Let's do that again. Okay, so the region we had was this. This was the line y equaled 1, and this was our region. And now we are, so this was 1, and we're revolving it about x equals minus 1. So x equals minus 1 is right here. So anybody want to show me the picture that they got when they did this? I don't see anybody with their picture up to the screen yet. I have one person that's excused on their camera right now because they're in a car. Okay, good. All right, so Lawrence, can you put that back up, please? All right, so now when you revolve that region about x equals -1, what does it look like? Okay, I think I see a couple people. Maria? Okay, that looks good. I thought Xavier, I'm still trying to go back to Lawrence too. Maria has the right picture. Okay, Donye, I need you to revolve it. That's the right region. I need you to revolve it. Okay, Lawrence, that's perfect. Okay, so if y'all can see Lawrence's picture, that is absolutely perfect. Okay, so here is the line, x is equal to -1. Okay, so here's x equal to -1. Then I'm going to have the same picture on the other side. So now I'm going to have here, I'm going to have a line. And then I'm going to have my parabola coming down like this. And then I'm going to have the line like that. So here's my region. Okay, so let's label things here. X is 1, X is 0 here, X is -1 here. Oh, I wrote -2. Well, how's that? X is -1 here, X is -2 at this point. Okay. All righty, so now what do we need to do? You guys are supposed to have this problem finished. All right, so now that I've revolved it, what am I looking for?
You said x is -1?
Yes.
I did something wrong because I already put -1 right there when I did it.
Okay. Yeah, it was x equals -1. That was here.
But when you okay, okay.
So revolved about the line x equals -1. Okay. All right, don't beat yourself up too badly if you read it wrong, but you gotta make sure you're reading this thing exactly what it's supposed to be. Okay, so now what do I do? How do I create my shell? Please help me. Where is my soda can? I don't have a soda can yet.
We have to pick an X value.
Okay, so I have to pick an X value inside the region. Okay, here's my X value. And then I draw a line.
I can't see the screen. I don't know if it's just my computer though.
Anybody else having problems seeing the screen? It says I am sharing. You can, if possible, you may want to go out and come back in.
Okay, I can see it now. It just popped up. Thank
Okay,
you.
good. All right, so that's where that line is, and that line's going to be in the same place over here. And then when it gets revolved, it looks like this. There's my soda can, yay. Okay. So I need to find the radius. What's the radius of my soda can?
Would it be -1 minus X?
Okay, we have to think, don't think in terms of what is on, the numbers you see on the number line. Think in terms of if you were actually measuring something with a ruler.
Would it be -1 plus X?
Okay, you're getting there. Who said that? Who said -1 plus X?
Gustavo.
Okay, Gustavo. All right, so now you're almost right. So this distance from here to here is X, right? That distance is X. And then how far is this distance?
-1.
How far? Okay. How far is the distance? If you have a string, how long is that string?
Would it be 1?
Is the string -1 length or is the string length 1?
1.
Good. Okay, so now this distance from here to here, so this distance from here to here is X. And this distance from here to here is 1. Okay, so the -1 plus X is a good thought, but I want you to think in terms of if you actually had a string that was of a particular length. Okay, Gustavo, do you see now why it is X plus 1?
Yes, ma'am.
All righty, good. So my radius is X plus 1. What's my height?
The height be the X squared.
Okay, almost.
X squared minus 1?
Almost.
1 minus X squared.
1 minus X squared. Okay. 1 is the tallest. It's 1 all the way to the ground.
Yeah.
Then you subtract off X squared. I only want this piece right here. I want this piece from here to there. That's all I want. So if I take this length, which is 1, and then I subtract off that length, which is X squared, then I end up with 1 minus X squared. So I get 1 minus X squared. Okay, so now what's the volume? Where does the X start? Where does the black line start? What's the furthest left it can go? And still be in the region.
-2.
Yeah.
Okay, here's my black line. It has to stay inside the region.
Zero.
Okay, good. The furthest it can go is it can go all the way down. It can go all the way over here. So the furthest the black line can get is here. That's 0. Once it gets there, I'm out of the region. The black line can get all the way up to here, basically to where x is equal to 1. Then I have 2 pi times my radius times my height, and I'm done. Okay, any questions about that?
So typically, if I saw a problem like this, I just know, like, from my experience with the previous ones, I would just assume that r of x is equal x. So I'm curious as to when that would not be the case as seen here. Is there?
Okay, I'm getting ready to give you one. Okay, so yes, in the previous problems, remember the radius was just equal to x. All right, so I'm going to give you a different problem. All right, so we want to use the shell method to find the volume of the solid generated by revolving the region bounded by, okay, this is a toughie, so I'm gonna have to tell you what this is. I'll show you what the picture is. Okay. About the x-axis, the first one we're going to do is about the x-axis. And then the second one we're going to do is the line y equals 1. Okay, so let me tell you what this curve looks like. And the y-axis. Okay. 2. All right, so the curve is x is equal to 12 times y squared minus y cubed. Okay, so this crazy thing looks like this. Okay. Actually, it should be a little pointier. I'll draw it again. That's what, well, this should curve in. Okay, so this is the curve x is equal to 12 times y squared minus y cubed. Okay, this is y-axis. This is the x-axis. This point right here, this is 1. Okay, that's all you need to know. All right, so here's my region. And I want to revolve this region first about the x-axis. All right, so when I revolve it about the x-axis,
Professor,
yes,
can I get like some time to like do it myself to see if I understand the concept first?
that's what I was getting ready to say. So now I want you to revolve it about the x-axis. This is a y problem, so this one is different. So this one is going to be the volume integral from c to d of 2 pi. You're still going to have a radius, but it's going to be a function of y. You're still going to have a height, but it's going to be a function of y. And this is going to be dy. Okay, so I still want you to do this one. Okay, I'd like to be able to see what your pictures look like, please. You revolved it around the y-axis. What does your picture look like? Oh, that's excellent, Gustavo. Excellent. Okay, anybody else have a picture? If you want some help on your picture, hold it up. Deara, did you
Yeah.
get a picture yet?
I mean, I got something, but it's really nothing. That makes sense.
Okay. Now,
Like,
if you're revolving it about the y-axis, identify the y-axis and then just flip the picture over.
yeah, so that's what I did, but
So you should have something that
I'm
looks like
guessing
this.
it's the radius part.
Okay, we're getting there. Good. Do you have, is this your picture?
Yes.
Okay.
Hold on.
All right. So now this time we're revolving it. So when we revolve it, the line that we choose is we have to choose a y.
So would it be x squared?
So choose a y
X squared?
and then, nope, just choose a y just right now. First choose a y and draw your line. And then you should have the same line on the other side. And then when you revolve it, you get your circle. And there is your shell. Okay. So we need to find the radius and we need to find the height. Where's the radius? Our soda can is laying on its side. I don't have a soda can because I just don't. Here's my shell, is laying on its side like this. So its radius is in there. There's its radius. Let me turn that again. There's its radius. Actually, y'all are looking at it this way. This is the way it should, y'all are looking at it. There's its radius on the inside. So what's its radius? It goes from 0 up to the radius.
Is the radius y?
The radius is y. Okay. So why is the radius y? Because the radius is this distance right here. That is the radius of my shell. De'Ara,
Yes.
do you see the radius now?
Yes.
Okay, it's laying on its side, so it's a little more difficult. All right, so if
So,
that's,
Sorry.
yes,
So you just have y. So would you, do I just put y too?
that's exactly right. So it's that height. So the radius is just y. Okay, now this is the harder one. What's the height?
So if we're looking at the height, you would look at the x-axis.
The height, that's right. So the height is that's exactly right. So the height, I should be looking at the x-axis. Okay, so yes, that is correct. Let me find. So the height is there. So how far, if this value is y, what is this value? If I tell you y, how do you find that value? How do you find this x value right here?
We just use the formula 12.
We use the formula. Good. So that if whatever y, remember y is the value that's arbitrary. So whatever y you're looking at, the x value is 12 times y squared minus y cubed. So that's the height. Even though it's laying on its side, that's still the height. Okay. Where does the y, what's the lowest value that that black line, which is now purple, can go? Where can it start? Remember, it has to be 0. Good. And how far can it go up?
1.
1. Okay. 2 pi y times 12 times y squared minus y cubed dy. I can pull out the 24 pi, get the integral from 0 to 1. I'm going to have y times y squared is going to give me y cubed minus y times y cubed is going to give me the y to the 4th dy. This is an easy integral. 24 pi. I'm going to get 1/4 y squared minus 1/5 y to the 5th, evaluate between 0 and 1, which is 24 pi. And then I'm going to get 1/4 minus 1/5, which is going to give me 24 pi times 1/20. Okay. All right. I want you to set up the problem for when revolving that around the axis y equals 1. And we will do that in recitation tomorrow.
I have a question.
Yes.
So when right there, whenever you go from 24 integral to 0, 1, y3, how does the y3 turn into 1/4 y squared?
That should be y to the 4th.
Okay,
Thank you.
no problem.
No problem. Thank you. Thank you. I wrote it wrong. Good catch. Somebody would have gone home and been like, oh my God, I don't know what I'm doing. Okay. Let's see what is next for us to learn. I am thinking that it is length, and that is something I actually like. Arc length. Yes, arc length, arc length. Okay, so we're going to do arc length. Okay. So it is so easy to determine the length of a straight line. We just take a sheet of paper and we measure it. Oh, you know what? I want this to be another section. So let me stop this.